Yeah, started.
So our first question is like lowest common ancestor of deepest leaves. So we are given the root of a binary tree and we have to return the lowest common ancestor of, excuse me, lowest common ancestor of its deepest leaves. And they are just giving the definition like node of a binary tree is a leaf if it has no children, and the root depth is 0, and if the depth of a node is d, then its children will be d plus 1. And lowest common ancestor of a set S of nodes is the node with the largest depth, such that every node in S is in the subtree with root A. So for this, like this is the leaf, right? So this is the at the deep level. So their common ancestor is 2.
Mm-hmm.
And yeah.
Yeah, can I ask here, if we would not have 7 and 4, yeah, if just we remove 7 and 4, what would be the answer?
It should be the root, I think, right?
3, yeah.
Yeah.
Oh, I
Because
see.
that is at 0th level, and this is at 0 plus, I mean 1 level, 5 and 1.
Right. Yeah, that's a good one. But actually, we should get it clarified, in that
Yeah.
case.
Yeah, that's a good observation.
Yeah, because at the end he might say, okay, I just want the left subtree, give some definition to that, or maybe some bias to it. Yeah, I'd never know.
Yeah.
Yeah. Okay.
So how do we go?
Okay. So the basic way, brute force, right?
Yeah.
Hmm.
Brute force here. Yeah. Okay. I mean, there is only one, right? Or will there be brute force?
Well, brute force, what I was trying to think is, first go and try to find the depths, right? Okay.
Okay.
If you'll have to use some traversals,
Traversal.
right?
Yeah, yeah.
Yeah. And then when you are going, you store them, something like that. But then how long deep you go? Maybe I start with the DFS traversal, anything, maybe a pre-order or an in order, and then keep
Post.
on
Okay.
post order, right?
Post order would be better because that would give you the deepest one, right? From bottom, extreme bottom, you'll start and then.
Well,
So
I would say anything should give, right?
in case of
Yeah,
like
yeah,
the thing like Nick mentioned, right? It, we don't have 4, 7 and 4. You go deep and you get a leaf. Can you scroll up a little bit, Shashank? And then you go up and you see, okay, you will find that the common ancestor. Can you scroll down a little bit? You see the common ancestor is of 6 and 2 is 5, right? And then you see common ancestor of 0 and 8 is 1.
Okay.
And now you have 2 common ancestor, and what you do?
Then
Because
that's
they
not.
all at the same level, right?
Yeah.
Well, I would say, okay, okay, take whichever is the deepest, pick up 2 of them. So maybe in this case, yeah, I got your point, because so if I do a DFS traversal, like keep coming from first I go 3, 5, 6, I pick that, okay, and then I say this is my first deepest one, 6. Then I go to another 2. Then I say this is my second deepest, but still I have to traverse the whole tree, okay. So then I come to 0, and then I'm having a second one. So then actually we'll have to decide on what to do, either we take 0 or we just leave it.
No, the common ancestor of 6 and 2 is 5, right?
2 and
But
6.
you are not going to return that because you still have to explore all the leaves of the tree.
Right. But like, so, the first one we say, okay, the first common ancestor of 6 and 2 is 5. And then we keep going and we say, okay, the common ancestor of 0 and 8 is 1.
Mm-hmm.
right?
Mhm.
So how do we return 3?
Yeah, so that's the very challenging part, right? So they are saying very cleverly, you need to find, uh, go to the deepest level and find the deepest leaves, okay, and then find a common ancestor. So for us, our definition of common ancestor is for only 2 nodes, but that's not the right one node, right? That's not right definition.
And
So
deepest. Okay, go ahead.
so what I was thinking, so to go to any depth, whatever it is, and then whatever depth you are, okay, now if you are at the third level, so whatever nodes are coming at third level, you keep on collecting them. That is the way you'll have to do, okay? Or else if you get a fourth level, like in this case, then you discard the third level and start forming another level like a fourth level. Yeah, but in that case, if we have one node at third level and one node at fourth level, what do we do? Yeah, that's another thing. Yeah.
Well, if it third level and fourth level, we take the fourth level, right? The deepest one.
But in that case, I just have one node at 7. So the way it is like in 2 and as 7 or 4, whatever those nodes are. So I have only one node of that. So then how do I get back to my third level, right? Yeah. You got a point what I'm saying, right? At the
Yeah.
node 2, instead of another 2 nodes at level 4, I have only one node. But still I have to find another else depth, like a level 3. So in that case, you'll have to pick 6, right? So because that is, it is biased to left sub. Sorry, Sang. Yeah, go ahead. Yeah.
No, no, I mean, I was saying the same what you were mentioning. I thought that since they're asking deepest, so we'll keep on moving till the extreme top because that would form the deepest one, right? Like for
Right.
2 and 6, 5, for 0 and 1, 8. So that is still not the, at the, for the leaf node, they are not the, what do you say, at the deepest. One more level till the point you hit zeroth node. So that would be the more, at a greater height from the leaf. So that would give, that point I was just mentioning.
Mhm. Yeah, but yeah, I
It's
think
like,
right. So maybe they don't have those test cases, or yeah. Frankly, I don't know.
yeah, it's a little
Yeah.
bit.
Mm. It looks very easy, but if we encounter or come across such a test case, like instead of 7, 4, what are the nodes we have only 7, then the way what I was saying, the brute force won't work, right?
Yeah.
So you'll have to find some better way of doing it. So the brute force really won't work, even if you find some brute force which will TL, it's fine, but that's not going to work in this case, correct?
So
Yeah.
we have 7 and we don't have 4, not 4. Then
Mm-hmm.
5 would be the the common ancestor, right?
Right, right.
No, for 7 and 2, it will be 2 only, right?
No, he's saying you just remove
We don't
4.
have 4.
Yeah, if you remove 4 also, that means 2 and 7. So 2 and 7's common ancestor is 2 only,
Oh, yeah, yeah. Yeah, you are right,
right?
Shashank. Yeah. So 2 should be the common ancestor.
Common
Correct.
ancestor.
Yeah.
So it, the common ancestor does not need to have like both children. They
Yeah,
have only
one.
one child would be okay.
Hmm.
Okay. So in that case, we'll have to do it that way. Okay. Whenever we get a node at depth 4, in this case, if you only have 7, okay, so then we'll have to store its parent also as a
And then,
second one. Oh, okay. Okay. Then that should work in that brute force. Okay. My bad.
yeah.
Okay. Yeah. Hmm. Okay.
So
So what is a better way of doing it?
better is like you start from the bottom, I mean leaves itself,
Okay.
and whenever you proceed to the next level, you increase the level by 1, right? And just
Mm-hmm.
keep on maximizing the max depth.
Okay.
Wait, how I still don't get it. Let's say how would the brute force work if that we don't have 7 and 4?
Brute
7.
force will still work if we have all 6208.
Then we return the root.
Yeah, then we'll have to return the root because we'll collect all of these together, and then return the root.
So can you please state your brute force again?
Well, I was saying, do any DFS traversal. Okay. Start from 3 and go down. Like you are doing a DFS, so you'll always go to only one node, one leaf node at a time, right? So whenever you come to 6, which is a level 3, so you'll actually start something storing all these at the lowest level. So initially when you are at 3, you'll just store 3, okay, because it's level 1. Then after that you come to the next level, next node, which is 5. So you know that the 5 level is 2. So and whatever you store for 3 was at previous level. So you will destroy that and then store 5 in that. Okay. So then you come down again on 6, you will have level 3. So you'll destroy 5 and then you'll start storing 3 with the level 3, right? So you'll have some variable maintaining that max level so far. And then when you come to 6, you know the level is same. So you'll put that in the your whatever those collection arrays. And same thing you'll do for 1, you'll just discard it because it's level 2. Then you come to 0 and 8. Then you push that in that whatever that level you have. And then when you have all of those, but while you are doing this, you'll have to collect all of these nodes also, the path, the whole path, because you'll have to go back to the root, right?
Yeah. So the post order traversal which I was saying is this only.
Oh, good. Yeah.
So it's like if my root is none, there is no root, I'm returning none. I have my result variable, and I'm initializing my max depth to -1 and passing it in a helper function root, and the initial level of the root is 0, 0,3. I mean address of 3. So you run here, come here, and here the real thing. Initially your depth is 0, and your this what you say max depth is -1, right? So max depth will be 0 initially. Now, if you are at the leaf, like if no root is there, we'll return this left. Otherwise, whenever you go to the next, it's left and right, we increase the level by 1. I mean, 3 is left, 5, and 3 is right 1. The depth will increase by 1, is what I'm doing. And if the depth of all left and right and all the 3 are same, then whatever what you say, in the result, we are returning that particular root as a common ancestor. And at last, we'll have the max of left and right. Right.
Okay. Okay. So you're calling this helper function as a post order DFS, right?
This is post order, left, right, and then performing operations on.
Oh,
Main.
okay.
Yeah,
And that's a very optimized solution, right?
yeah, this post order. Oh, yeah.
So where the max depth, the max, oh, you track the max depth, right? Okay.
This part here, and then
The max depth is like a global variable.
variable here.
Okay.
Of the global variable of the I mean,
Of
is
the
that like
class.
is that max depth of the root or of the current node?
Max depth. I didn't get what you are asking.
Max max depth okay of the global. Huh?
Yeah, it's a global. So it will be whatever is the greatest so far.
Till now, yeah.
Right. Yeah.
Mm.
So he'll go to each and every leaf, and he is not because you don't know at when you are going which node is going to be your leaf, right? So
Yeah.
you'll come to know only when you go to line 18 and 19.
Mm.
No, not 18 or 19 in this case. You don't check for not root, right? Okay, return the
Yeah.
depth. Okay, yeah, 18 and 19 because that's not root, right? Yeah. But it's just doing it prior to that. So Yeah, but even if you do after that, you're not going to come inside it. Okay,
in
makes
that
sense.
case.
Yeah.
It's like from bottom I'm starting 7, 4, and then checking and comparing. Like if the address of left and right both that is equal to the max depth, then that is your one possible. Yeah.
So when you add node 2, what would happen? What is
At two, two,
yeah?
right?
And then at that time, what could you annotate it or you try run the session?
Yeah, yeah. Let's do that. So first, I mean, what do you say? We are starting initially. We are here, right? Max depth is 0 at this point, right?
Okay, yeah.
Now what you are going left, roots left, you will go here, then you will go here. Now there is no left of it, so whatever what depth it will have, this will have 1, this will have 2,
Okay,
and it will return 2 2 here, right? Because after that we don't have any root.
yeah.
Now we'll explore this path. Roots right, you are going right, and you are right again. After that you'll have a call for left, right?
Mm-hmm.
So this will be your 2 and this will be your 3, and then it will return 3 over here, and then it will go for the right, isn't it?
Okay,
So it will also be 3. So at this point of time, what you are saying, the left and right both are I mean, both will return 3 to it, right? Which will be equal to your max depth also you have to keep track. So here it was 0. Now max depth become 1. Now when it returned here, before call we are doing, right? Now the max depth will be 2 at this place, right?
That will remain always the highest one. So after 2, it will remain 2 even if you go back to 5. So when you come to 2 also is going to be remain 2. But when you come to 7, it will be incremented to 3. Right?
Yeah, 2, 3. So now your left and right and max depth, all the 3 will be equal at this place, right?
Yeah.
Because you are returning 3 and max depth will get updated.
okay. So the cell max depth is 3 at node 2.
No,
Yeah.
at
No, no, no.
node 2, it will be 2 only because you just came from 6, which was the largest one, right? So, but when you go to 7, oh yeah, when you go to 7, it will be 3 and you come back again to 2, then it will be 3. Yeah.
Yeah.
That
That
the left is 3, right 3. But what about like the cell max depth at line 22? What
that
value?
will be 3 only, right?
He is just comparing them. If they all are equal, left and right is equal to max depth, right? So then you'll have to return the root in this case, correct? So they are all at the same level.
Yeah.
Okay, that's a global max. Yeah, that's one.
Because he's returning max of left and right, isn't it? So whatever of these two is there.
Okay, yeah.
Or we could have maintained a dictionary also, right?
Yeah, so I was doing it that way, okay, but I
Yeah.
was doing a BFS way, but it's too much of coding in that, right? The implementation is too much, and then when there is too much of code, you tend to make a lot of mistakes when you are coding, right? So that becomes very cumbersome. But the way you did it's very lean. Yeah,
This is
uh-huh.
so BFS only, right? I mean, not exactly BFS. It's a post order, but every time you are same thing. You might also be doing in the BFS, popping, and then for the next level you are increasing the level by 1, right?
Yeah. So, but yeah, I was doing a complete level order traversal. So, but that
Yeah.
would be a sort of too much for that algorithm, right? So, this is the best way to do, I would say, uh, for the interview per se. You can explain all the approaches. You
In
should
the
at least know them, or maybe we have been discussing so much, so we all know about those things, right?
yeah,
So some of them, but this is something which is very hard for me to recollect most of the time.
exactly.
Right, yeah.
What would be the intuition on line 22?
22 like address. What you can say? Left and right is storing the address,
Yes.
right?
The address, not the. Oh, okay. I thought that the count. Okay, the
No,
address.
no. Address here, that is 3, 3.
Okay.
If the address is same, that means they are pointing at the same place.
Mm.
So okay, what line 22 you're saying left and right are address?
Yeah, it is address only. I mean, reference of that node, which is in terms of depth.
But then how are you comparing that with the max depth in that case? Max depth
No,
should be the count, right?
yeah, max
Well,
depth will be sure. Yeah, I mean, not exact. I mean, not that reference. What do you say? The reference in the form of height I'm taking, like, because whenever I'm going like reference of 3 is 0, then when I come to 5, reference of 5 is 1. That way, because count it's not taking, right? Cell root dot left and depth +1 we are passing. We are not passing any value here.
you're
Is
not
it?
passing the value,
Mm.
but you're what, because that becomes slightly different to correlate in Python.
Maybe yeah, that.
Yeah, so because I thought you were returning, okay, because anyway you have to return that value, the root, okay.
For understanding sake, you can consider it as a count only. I mean, the height or the depth.
Yeah, but then how, what do you return? When you return on line 23, see you are returning the root, correct? So that is the node you are returning, correct?
Oh, he returned like 24. It's left
24,
or
right?
right? Yeah,
Oh, okay,
it's
okay, okay.
left or
Sorry,
right.
sorry.
How if it's the address, how could you compare the max?
Right, right, right. Yeah. So he's
Then it will
returning that on 23. He's just returning that as a res, and that is a global variable, right? Line.
max depth.
Okay, my bad. Yeah. That I was wondering how they do it. I thought there might be
What it will
something
be then?
automatic what Python stores as a pair.
In,
Okay.
okay, no, it is returning the value.
Yeah, this it. Yeah, it had to because you get the max, right? You cannot compare the max.
Compare.
Address.
Yeah.
But the value itself is the reference only for that node, right? Or like
That is
three
a
reference.
see. We are always returning a value, correct? Left and right is
Yeah,
a value. No, sorry, value in the sense the count.
count. Yeah.
Okay, so then they return the value of cow left, cow right, cow, and then and the max depth. What would be the intuition on line 22? Because you have
Because
returned a node.
all the levels are at same, right? The level
Uh,
of left and the
Yeah,
level of right.
so 7
Yeah,
and
you
4, the case for 7 and 4.
yeah.
right.
So
Yeah, I
you
get that
need to know
one.
that.
But then when you are node 2,
Mm-hmm.
you say that it also equal to max depth.
Mm,
So when you are going back, you mean to say?
I think yeah.
But in that case, you won't be able to, because when you are at 2, you know that you have stored the value. Then you go back when you are actually doing a backtracking, some sort of like that. So from 2 to you go to 5 in that case, correct? So when you go to 5, so that's not going to come, right? So you're not going to get that situation on line 22. So your left and right won't be same because
Got it.
now your left is 6, correct? Mhm.
Hmm.
So then you will return something else. Okay.
So
So if it is not,
go ahead.
Yeah,
Oh,
as I understand, if even if we remove just 4, it will return 2 because in case of now root, we return depth. Yeah.
yeah, for null root we are returning depth.
So if we remove 4, it will still return 2. Yeah.
yeah,
Oh, you are telling if you remove 4, right?
Yeah,
mm,
just for 1. Yeah.
it will still have to return 2, correct?
Yeah.
Yes. Thank you. Sorry.
Can you scroll down a bit, Shashank, in your code?
Oh, okay.
No, the code. So okay, when they are not equal, then you just go and return whatever is the
max of
max of left or right. But then what about your node? How do you store the node? Okay.
node. I mean, this is storing the node only, res, right? The common node.
But that is being stored only when left is equal to right and it is
Yeah,
equal
the
to the self max. Now the way
value.
Nick was saying, right, if we had 4, we didn't have 4, correct?
Okay.
So in that case, when you are at 2, your left will be a different value. Maybe it is value 3 and 7 is, which is the right, or left is 4 and right is 3 in that case, correct? Because
Right.
if we did not have 4 in this case.
Yeah.
Right. So at that time, your left and right values are not same. They are also not equal to self max. So then how are you going to return that?
So
So
let me
you'll
change
return the 4. Oh yeah, you'll return the max of that, correct?
left and right. This one.
Yeah. So you'll return 4 in that case. Okay. But then
3.
how are you?
3 will return max of left and right in that case. 4 why?
Why? Big. Oh, okay. Sorry. So this will be 3 and this will be 2, right? Okay.
Yeah.
Okay. So you'll return 3. But then where are you storing this value in that case? So you're not going in this if condition, correct? On line
No.
23. So then when you will go in that if condition, because you'll have to store this value, right, to return it back.
Then it will return false in that case for if 4 is not there. Let's check the output then first.
No, I don't think so. It will work, but I'm not understanding it.
Which one? 2, 7, and 4, right? 4 I have to do. Okay. Let's check it. It will return. Oh, it's true.
Return 7.
7 how it is returning?
Oh,
7 is the deepest node. I
deepest
think
node. Yeah.
this is why.
So it is
7
not
is
going to return the LC. In that case, it will return the self node. If it is a single
Oh.
node,
Hmm.
that is accepted. So our definition was slightly incorrect in means, right?
Yeah.
Okay.
Yeah. Then for 2 and 7 it won't be 2. It will be the node, because 7 is the what you say least at the top bottommost level, so its left and right is null, so 7 itself will be returned as a ancestor of itself, LC of itself, right?
So if you remove 6, 7, and 4, what would be the answer?
In that case, it should be the root.
7 and 4, right? Then yeah, it should be 3 then, I think.
Three
Yeah,
or
it is
5?
3.
3.
Yeah, it is a 3 subtree rooted at 3.
Why not return a 5?
Well, it won't, right? Because you have to take the LC of all the 208.
Yeah.
That will be the
But
LC.
all of them are same in level, right? 6, 2, 0, and 8. So you have to consider the common ancestor for all the 4.
Yeah. So
Okay.
we had that mindset already. Like whenever it is LCA, we have to look for 2 nodes LCA. You know,
Yeah.
that's wrong. Right? Yeah, that's not the way it is. This is slightly different. We need to understand that. Okay, cool.
Actually, in this question, we need to find this smallest subtree with all the deepest node. This is why when we were removing 7, 4, 2, and 6, no, 6, 7, and 4, then the smallest subtree with all the deepest node will be rooted at 3.
Okay, so we have to return the
So this one,
subtree, right?
Yes,
this one
yes,
is
yes.
with all deepest nodes.
the main aim was not to find the LCA, but to return this smallest subtree with all the deepest node. If we
But
take all the deepest node, then its root will be the LCA of all those deepest nodes.
Mm, yeah, I think you're correct, but could you please reiterate again?
Uh, so if so, as it is stated that we need to find the main question said that we need to find the lowest common ancestor of its deepest leaves.
Uh-huh.
So so if we take all the deepest leaves, then uh, there can be more than one. There can be more than two deepest leaves in the tree. Then in that case, we need to find the uh, lowest common ancestor of all the leaf node. Then it will not be the lowest common ancestor of any two leaf node.
Mm.
In that case, we need to find the whole subtree which is which has all the leaf nodes.
Mm. So all those deepest leaves should be a part of that subtree.
Yes,
Okay.
yes.
But then when we did in the case of 7 and 4, we removed 4, right? So 7 did not had any root, and therefore we are actually returning 7. Yeah, And that's slightly hard, right, on that case, because if it is 7, if you have only one
Yes,
7 at level
seven is
3,
the since 7 is the deepest node. This is why we were returning only 7. It
yeah,
had
but
no
then in that case we should return its root, that is 2, right?
no. But if we return 2, then we have to consider all the roots which are at the level of 2 also, which is 6, 0, and 8.
Mhm.
like, then why
Okay.
did they write this LC that what was the significance of that? Lowest common.
Okay, yeah, so at least okay. Yeah, it's
Will it-
tricky.
Yeah.
Yeah, what you say makes sense, but usually, because 7 is not a subtree and we know it is at some level. Okay, so maybe if we are only with one node, one deepest node, then we just return that. So maybe we'll have to make some sort of understanding, something like that, right? Yeah. Okay. Okay. No problem. I think there is some we'll have to remember if it's not an LCN, if it is a deepest leaves, right? So it is slightly different way, or maybe just mm, um, draw this on a whiteboard in an interview and just explain what exactly he wants and then work on it, right? So at least to scope our understanding there.
That-
Yeah, that's good. Yeah, no, thank you, Abhishek. Yeah,
Okay. Can go to next.
yeah,
Yeah. So this is a image overlap. So two images are given, image one and image two of same size. They are represented in a binary form, and we translate one image. We translate one image, however, we choose sliding it all the four directions, any number of units, and place it on the top of other, like superimposing. After the overlap of this translation, the number of positions that have one in both the images. We have to return what is the largest possible overlap. The rotation is not allowed. Okay. So if we put this image over this, right? So all the ones like this one will go with this zero. So it will be zero. Right. So we slide image one to the right by 1 unit.
right. So you
Okay.
just slide to the right, again right, and then you're
Two right and one
making it
down.
down. Okay. So in this case, what we would do is we actually take the whole image and then move it around. Hmm.
Yes, I would like it. Like move down, right? Move to the right, move down.
Mhm. Initially, when I looked at this problem, I thought we could do something like a prefix sum, and just find out if we have similar values when we are actually looking for the differences between the origin and the destination, something like that. But that will be almost the same like doing moving the image, right?
Mm.
Yeah.
Prefix sum, and does it work?
No. I was just thinking loud and then thought might be that might be one solution, because usually when we come to this sort of matrix and we want to count the number of ones and all that, we try to use it, right? So but that doesn't work here.
We also have prefix sum for the matrix, right?
Yeah.
And
2D prefix.
2D prefix sum, yeah. So that won't work. So what is the best way to do in that case? So if you are doing a prefix sum, why not actually move them, right? So that would be a brute force way of doing it, correct?
I thought prefix sum maybe shorter because if you do the prefix sum of this one, right? And then you have the prefix sum of this one.
But in that case, you will have to still find out the difference, right? At each and every stage. So when you want to find, now in this case, you said you have the prefix sum over here, right? So you get this value, maybe something like a, right? So but you at this point, if you try to look this value, this will be b, correct? But the why it is going to be because you'll have to look for this value c, and if you take the c and subtract it from b, then you will get a, correct?
Yeah.
So when you get that, so when you're actually going to do a difference, but then in that case you'll have to do a difference at from this one to here, right? So you'll have to do from here to here everywhere, right?
Yeah.
So in that case, it will too much of computation. It might work, but it will be too much of work.
Yeah.
So let's say what would be the brute force?
Yeah, brute force will be just to actually take uh, the way he's explaining here, right? But you don't do it at a like he's doing it, move to the right and go down. Instead of that, you just move one row at a time, okay? Then keep on moving all the rows, or maybe then when you move one row, then you move one column also, something like that. And then always look at the overlap, whatever it is, and count the number of ones, and whatever is the max so far, you return it at the end.
So when you move to the right, you fill the left column with 0, right?
You Well, you are only moving one image at a time, correct?
Yeah.
So when
Yeah.
you are moving one image, right? So if I'm having this image, right? And if this is my first image here, right? And then I want to move this image too. So maybe I will just move this image to here like this. Okay. So my last column is out of the bound of image one.
Yeah.
So
And the
I won't
first
actually collect this. Yeah. Only the first two. I'll just find out what is overlap.
and you fill the first column with all 0.
You don't have to, right? Because you are actually just moving the images. You are only playing with the indexes, correct? You are not actually disturbing the images.
Yeah, but then you have to like put 2 image on top of one another kind, right? And then say, okay, at this location, if it's 1 on both image, like
Correct.
you have to overlap them.
Yeah. So now when I have an overlap, in this case, I will see now this is zero, right? And for this is also zero. Just I'm ignoring it. So for this is zero, then this is zero, right? So then I come here, it is one, and then I look for this is zero. So I just ignore it. But here in this case, I have one, and then this one. So then I take that one. But this is zero, and so for this also I'm just ignoring it. And this one is 0, so I ignore it. So it's only 1 in this whole overlap, right? So I'm just looking at the values and I'm only playing with this indexes. So whenever I'm comparing this coordinate of this particular cell, which is at row 0 and column 1, I'm
Okay.
comparing with row 0, column 0.
Okay.
That's the only difference, yeah.
And we don't need extra memory.
We don't need, but we need too much of computation, right? You see, we are going so many ways. Yeah.
Yeah.
Okay.
What is the constraint on the row and column? If it's small, we can do it, right?
Yeah, it is small, not so big, I think, right? It's almost 30, yeah. So that might even work in the brute force.
Yeah, it should. Yeah.
Okay. So what is a better way of doing if that is not the best solution, even if it might work, but still you would have to do slightly better on it.
Yeah. Then again, extra space, extra array you create and mark where all ones you have seen, right? And
Come again, what was that?
I'm saying like wherever once you have seen in your matrix, you take for image one array, which all areas you have seen the one will mark all those positions corresponding to the same row in the second image. Like let me. So this I was saying, like I'm going through the matrix, right? This is one, like it will contain all the places where the one is present in your matrix, right?
Okay.
So we are storing all those coordinates where the one is present in both in your first array and in the second array. So 1A and 1B.
Okay.
And yeah, and then for the vector overlap, what we are doing after creating these two arrays, we are checking all the possible combinations. Like we take one coordinate for one coordinate of this, we go through all the coordinates of B and just take the difference of X and Y, I mean I and J coordinate. And if you find that you have already seen that, we increase the vector of that by 1.
Oh, that's a dictionary.
Dictionary kind of, yeah. And every time just keep on updating the max overlap by taking that value from the dictionary and this.
Because if the difference is same, it means they are
So, overlap.
same orientation. Okay.
Yeah, or same orientation.
Okay. Okay, so you instead of going through, you're still going through the way what we were discussing in the as a brute force way, right? But here you are not going through the ones non-ones. Okay, means zeros. You are only going through the one cell.
Yeah.
And then comparing their coordinates. Yeah, that makes sense. But only in the worst case, if all were ones, then you will be almost doing the brute force, right?
Brute force, yeah.
Hmm.
Then prefix and
In that case, you could actually do some optimization there. Yeah, if it all is one. Yeah, yeah. You never know. It might be almost equal to all, almost all are one. So then it will be a problem. Yeah. Okay. Yeah. So that should work, right?
Yeah, it should.
Okay.
Could you annotate and draw something?
Yeah,
It's
yeah, sure.
1A pen only if it's 1.
I didn't get.
Oh no. Yeah. So for 1A, you append you set the value. Yeah.
1A, this array will contain all the coordinates wherever you are finding one set as one in your matrix, right?
Okay.
And this array will contain the coordinates of all the
B.
positions of matrix, yeah, wherever you see one. Now I'm just creating a dictionary, right? And now for every coordinate in B, I'll explore all the coordinates in B. It's like kind of all the possible combinations I'm checking and
Okay.
subtracting I I and j with j. If it is same, I mean the vector which you obtain, if you have already seen in your dict, then just increase its frequency and keep on over what do you say, updating the max overlap every time. Necessary, yeah.
Okay.
Almost brute force only.
What is the data type of the vector?
Vector is a default dict int, like integer type.
Oh,
It's a dictionary.
Dictionary, yeah. With integer, I mean, yeah,
Maybe like an unordered map. Yeah.
kind of, yeah.
okay.
Yeah.
Yeah.
Yeah. So this is good. But the only thing is when you are storing in a dictionary, the key, you are storing a pair. That is a pair, right? Of two values.
A pair of values, yeah.
Okay.
Tuple, yeah.
Yeah. So in C++, either you store a pair or maybe you'll have to use a different, instead of unordered map, you'll have to use a map. Or else then convert both, because the value is only 30. So you convert that key into a key, maybe two integers together, multiply with some sort of a rolling hash. Yeah.
And then,
Yeah. Then store it. So that's only some slight difference we'll have to make. Yeah. Yeah. So this is a much better approach than the brute force way, right?
yeah, but at higher level, it's like a brute force only. I mean,
Not really, because only some of the corner case will be there. Okay. So
space also extra taking.
yeah, but usually when you have two images, when you want to compare them, the overlaps, there are some reasons why we are doing it, because you want to find the information, right? So if the information in this case is all one, so your image will be either of same color, right?
Yeah.
So then it doesn't make sense even to do this, because you do such things only when they are sparse information, right? So then this algorithm will be efficient. So yeah, it has its own applications.
Yeah.
So we had
Yeah.
that convolution approach also in the solution, right? So
Oh, dot product you are saying.
mhm.
Yeah. Yeah, you have, couldn't share it.
No, I'm just thinking loud, because I was just going through it and I saw that there's a convolution approach also. So he was trying to convert the whole thing in something. Yeah, good.
No, I'm saying he will superimpose image one on image two and take the dot product of one with zero, then one with this zero and zero with zero.
Mm-hmm.
Cell-wise dot product they'll do, I think.
Mm-hmm. So is that there an advantage, that one with this approach? Because I think that will involve a lot of processing, correct?
Yes,
So
space you can optimize, yeah.
space is optimized. Okay.
Because on these two metrics only you will play. You don't need to store any. So in that case, I think if the product is one, then only the image will be visible, right? One into one.
Mm-hmm.
Yeah. Otherwise, if it is one into zero or zero into zero, both the cases will be zero. So
It's just like the max overlap what you're doing here, right?
kind of, yeah.
And he's also doing almost like a brute force, but the way he was doing is actually uh, first overlapping the 0 0 location of image 2 with the n minus 1 n minus 1 location of image 1, right? And then moving it. So it comes to almost brute force, but only you are finding a dot product.
Yeah.
Okay. Yeah, but that's what they use for in image processing, right? The convolution.
Yeah, convolution operator. Kernel we use actually
Yeah.
to
So
get the
that's
dot.
what you'll have to convert into kernel and then use that. Yeah, so it has applications, but I think what you have displayed here, that is the at least the most best approach, right?
Yeah, simple
Yeah,
and
someone may find a better approach. You never know, future. Yeah,
You
but
can
array for
optimize
now, this is the
space.
best one.
Yeah,
Sorry.
space. I'm saying if space can be optimized in this, but it's not too.
But this is a very space optimized one because you're looking at one A and one B, those two arrays. Okay, so they are only taking the coordinates of the ones in both of the images, right?
Yeah.
So it is space optimized and also time optimized, right?
Yeah, time will be n square only. I mean, first matrix.
It will be based on what how many number of ones are. If the image is very sparse, then it will be very efficient, right?
But two for loops we are running only, right? To check
Yeah,
whether the set bit, I mean, set is there or
you are
opposite.
running two for loops for sure, but if you had only few, like only 10% of the ones in image one and 10% on image two, so you are reducing almost by to 10% of your n square solution,
Yeah, because most of them will be zero. We don't need to
right?
process.
Yeah.
Yeah. Yeah. Then we can switch to next. Yeah. So next is like we have to find n unique integers that sum up to zero. So integer n is given. You have to return any array containing n unique integers such that they are add up to zero. Like these are those five possible numbers which you add them will sum up to zero. And this is also one. This is also one.
Hmm.
Your target is to get zero using five integers. Positive, negative, or integer it is okay. It will minus infinity. Then it's 1000. One I thought like based on zero will go like number line we have. This is zero. One I'll go plus one. Sorry, minus one plus one. Again it is zero. Again minus two plus two, and here itself five. But they didn't display this as an answer.
You can use that. It is the way you do it.
Hmm.
So, but in this case, what I would do, I would include zero only when my n is
Odd.
odd.
Yeah,
Right?
yeah,
Yeah,
that's
yeah.
good observation. Yeah.
And if it is even, I just don't include zero and do exactly the way you are doing.
Both the sides. Yeah.
Yeah. So that should work.
But they haven't given the answer as this one. Okay, they might not have
That's fine.
mentioned.
Yeah. All answers are accepted, right?
Yeah,
Because if you look at the example two, right? So it is the output is minus 101.
yeah. Yeah.
Yeah.
Yeah.
So I was starting like I initially started with using odd values. Okay.
Mhm.
So if it is like if it is my n is odd, and in this example if it is 5, so I'll give three odd values. Take first like what I'll start from 1 3 5. Okay, and then I know that I'm left with only two values which are to be negative. So then I will just add 1 and 3, so it will be minus 4 and minus 5. Okay, but in the
Yeah.
case if it n is even, so I will have only 1 and 3 as odd value and minus 1 and minus 3.
In that case, yeah. Mm.
Yeah, so something like that. So yeah, that is also maybe I'll just.
When I was starting,
Uh-huh.
I assumed, okay, what if n is even, n is odd? So I had like a while loop for n is even, while loop for n is odd. But it turns out that if we do while left is less than right, if n is odd, the while loop stops when left is equal to right. At that point, so the pointer, the left and right pointer will basically be around in the middle of the array. So it will leave that spot at 0. Uh, if n is even, then left becomes greater than right, and while loop stops. It just happens automatically.
Mm-hmm.
Yeah.
Exactly. You want to share?
Yeah,
Yeah, I
yeah.
would like to see what.
Sure, sure, sure.
So let's see. All right. Fine now. So I'll show you my brute force operas first, right? The solution I came up in the 20 minutes.
Okay.
And this is what I did. So, okay, I knew I had to, um, so I knew the one way I could do it is, okay, so if I have three elements, I can start with one element as one, leave one zero, other element just a negative of that number one, and that's why I started with num1, right? Result, because basically the question is asking like, return me an array, return an array of size n such that n contains a unique elements and they add up to zero, right? So
Mm-hmm.
I said, okay, well, if n is even, then let me start from left, go to the end. Same thing if left is less than right, okay, give me a one, give me a negative one, left plus plus, right, and a num, and I did the same thing for if it's odd,
Mm-hmm.
then starts from one, always put the element first at zero, and do the exact same thing and return me the result. This works, right? But it turns out after I, looked more closely, it turns out that you can actually don't even need to do this. You can actually do this. So here I'm essentially doing the same thing. You know, starting at num, left is zero. Right stops at the end. But this logic, if n is odd, then it stops when left is equal to right, because left is less than right. So at that point, uh, both pointer would be around the middle of the array. So when Java, when we instance an array, everything defaults to zero. So we'll leave that spot at zero. So the value actually defaults to zero, like in the middle. So this will be like defaulting to zero. But if n is even, which means left becomes greater than right, so the while loop stops. So we don't need to do anything. So this will take care of both odd and even cases.
Oh, so you are always returning zero in case of odd value, right?
Exactly.
Oh,
Yeah.
okay. So what Shashank was saying, okay, so this is the way one way of doing it, right? Uh-huh.
Yeah. So yeah, interesting. But yeah.
Yeah, yeah. This is a good one. Hmm.
Let's
Yeah.
say, suppose, they put a constraint and say, the number cannot be consecutive number. The result cannot be consecutive number. And what we need to modify to make it work.
Oh, that's a good. Okay, well, if the result is cannot be consecutive number, then instead of adding num1, what I'll do is I'll just make a random number and add add a add a random number instead. I'll just make like a random function here, a random class. So that method will always give me.
Well, why not? See, what you are doing whenever you are incrementing,
Uh-huh.
so you're just incrementing like you have n num is equal to 1.
Yeah.
So your second num will be 1 plus 2. Every time you just increment by 2. So in
Yeah.
that case,
Yeah.
what you are going to do is 1, 3, 5. Okay. So they are not consecutives, right? And negative 1, 3, 5.
Oh.
That will
Well,
work, right?
yeah. I mean, if interview allows me to do it, I'll do it. But okay.
No, let's ask Leon about it. So is that what you are looking at,
Yeah,
Leon?
yeah, it worked, but that worked too. But I'm interested in, the generate the random number and then see how it works, because the
Yeah.
Oh,
mix
you
make
are
it
saying
harder, right?
generate a random number.
Yeah.
Huh. Mm,
So in the place of num plus plus, we can always generate random number. Can't we do that?
Yeah, and I'll have like a little private function that will generate them, or I'll just use Java's random class and create a random number. And
yeah,
instead
but
of doing num plus plus,
that is right. But if you
yeah,
generate a random number, so the next time when you are again generating a random number, you will have to put a condition so it doesn't generate a consecutive one, right? Consecutive number.
yeah, yep. And the negation will always be
The same
the
number, right?
yeah same number. Yep.
Mhm.
Instead of that, we can start the pointer from 2. So if we start the pointer from 2 and take steps of 2, we can, in the even case, we don't need to insert 0, but in the odd case, we can insert a extra 0 so the array size will become odd.
Mm.
Then we don't need to start from 1. If we start from 2, then we can take care of both the even and odd cases.
Yeah.
So I was thinking like, let's say you generate the random number. For example, in example 1, right, that happened, the random number, let's say -7,
Mm-hmm.
right? So now you have to know that the rest of the number, somehow, you have to sum them up to 7, right? So the sum will be 0, and then you can generate that random number. For the 4 number, let's say, suppose the first number is -7.
Mm-hmm.
The rest of the 4 number, we can generate the random number in that range, in certain range. So the
Right.
sum of them will be 7.
Right. So my helper function needs to make sure that.
Yeah.
Okay. Yep. Yeah, those are interesting constraint.
Right. Or else just go through, if we have n, so n minus 1, you keep on generating the random numbers, okay? And then you keep on adding, keep a count of, keep a total sum of those numbers. And at the end, when you want to put the nth number, you just put a negative of that number, right? So that also might work.
Yeah.
It will be a complete randomized number output.
One way, like a GP series also we can use kind of.
Okay.
Yeah. Was like, if we look at this pattern, what we see, first and last term is always 0 when you add it, right?
Are you sharing
First,
something?
no, I'm okay. Uh, Let me share.
Yes,
Just
You
just
want to stop
stop
my
and
share?
share. Yeah,
Then
that's
it
good.
can be fraction value as well. If we
What's
are taking the
that, Abhishek?
GP series. If we are
oh,
taking the
fraction.
GP series, then it will be fractional value.
What they are saying integer.
Yes.
I was just seeing this one.
Uh-huh.
So what we see, always the first and the last term sum is always 0, right? I mean, it's like everywhere if you see. So what they are doing, they're taking the first term a of 0 and the last term into n by 2. This is the sum of what you say. If you have to calculate this series, sum of the series, right? We have a formula for this.
Yes.
Like
I
the
think this is
first,
the arithmetic progression, not the
yeah,
geometric one.
yeah, sorry, arithmetic progression. Yeah,
Yes, yes.
yeah. So when you evaluate it, the first, what we say, the sum of first term plus last term should be equal to 0, right? And we also know the difference of the last term minus first term will be n minus 1 into whatever delta you have. So when you solve these two equations, we, what do you say? You can generate, I mean, with delta as 2 and first term as 1 minus 1, 1 minus n, and then you can generate the further terms.
This is
Then it will be one-liner solution in Python.
Yeah, it will be
in
one line.
Python, it will be one line, correct? Yeah.
I'll show you. Range. I don't know where it is. Yeah, this one. Range 1 minus n. With a difference of 2 we are creating. Even in C++. It's a formula based, but
Yeah, this is a good one too. Yeah.
yeah.
Yep.
So any other?
And what was the original one? What you were, what you
Original
did?
was this only. What Shuffle shared just now, kind of.
Okay, okay.
Like if it is odd, I'm adding 0 and just
Yeah,
adding the and negative of that number.
yeah. So that is what would always come to our mind quickly, right? So to start with, that is the best thing to do. Yeah.
Yeah.
Yes.
Then I guess if any more constraints are there, then we can change the uh, original solution.
Hmm. Yeah, there will be constraints for sure, because this being a very simple problem, then the interviewer surely put more constraints.
Follow up.
Yeah, and that's good. What we discussed about all those approaches, they are always helpful in such conditions, right?
Yeah.
Mhm. So, is there something interesting in the hint?
No, I thought that any related question, if they have given, that
Ah,
might be the follow up for this.
right, right, right.
Mhm.
Yeah. So it is exactly explaining the same what we are doing, right? The hints also.
It's also, yeah.
Yeah. Yeah, no problem. I think